All right, welcome back. Hope everybody's doing well. We've got one more lesson in this wrapping up I can do integration unit. And this one I think we've saved the best for last. You know how I am reticent, that's an SAT word, to use the word difficult, challenging, rewarding might apply. Traditionally, this is a challenging topic. Traditionally, I remember back in the day that this was a topic that actually gave me a trial or two. So, because the problems aren't as obvious to find. So, on the one hand, yes, but on the other hand, are they really? So, here's our rules. So, when you've got an integral that involves the square root, and all of these have the square root, so let's find what they all have in common first. You've got an a squared minus a u squared, you've got an a squared plus a u squared, and you've got a u squared minus an a squared. So the plus, that one should be easy to identify. Remember, a is a constant, u is your function of x. You're going to use these. Now, I don't remember these. I just do the substitution. So I'll show you some examples. What I've done is, for practice, I've posted an old quiz for lack of a worksheet. I didn't want you to have to dig out problems in the book, so I think there's 4 problems on a quiz, and I've posted the answer key to that too. You will still have your weekly, I can do 1 grade a week kind of activity in Canvas. It's already posted. It's still due Friday. It's only Wednesday, so you've got all day today, tomorrow, and Friday to do it. So I'm hoping that you do that. Tell your friends. I've put in grades from the last one. As of the last time I checked grades, 3 of you had not done it. So tell your friends to do it. You can do this. I'm not asking for too much. Are you going to college? Do you really think you're going to be a big boy or big girl someday? Yes, you are. So you can do 1 activity, certainly a week. But this is good review. Again, the underlying theme of this is I want you ready and strong next year. So even though we don't have very high expectations for you, I have very high expectations for you because I want you to be setting the curve next year at the college of your choice. So, trig substitution. When you've got the square root of a squared minus u squared, you're going to say u over a equals sine theta. And I actually write it out, sine theta equals u over a, and then make a triangle, etc. I'll do some examples here and kind of remind you. This worksheet, by the way, is on Canvas, so you want to follow through with the notes. And then you've got a practice set of problems, 4 of them right there. When you've got a square root of a squared plus u squared, use this substitution, square root of u squared minus a squared. So it looks a lot like this one. You're going to say secant theta equals u over a, draw the triangle, and away we go. Okay? So with this one, I've got x. Okay, that's nice. I've got a square root, though, of x squared plus 1. So it looks like our second rule there. So I'm going to say this matches the tangent rule. I'm going to say right here, tangent theta equals u, which is x, over a, which is 1. So tangent theta equals 1. That means that x equals tangent theta. Your whole goal is to substitute in with trig values instead. So I've got an x in my numerator. That's good. I've got this expression, though. I'm not going to say tangent squared plus 1 and try to do substitution there. No. Instead, I'm going to make a triangle. And I always make these first quadrant triangles. You don't have to worry about any signs here. But going back to your definition, tangent theta equals opposite over adjacent. Right? And that way I can solve for my third side here. Opposite over adjacent is tangent theta. So I'm using this triangle, opposite over adjacent. That means using the Pythagorean theorem, I've got the hypotenuse is x squared plus 1. Okay? So I've got x equals tan theta. Cool. I've got this triangle now. So one thing I can follow along here is say that dx, and I should have saved some room, dx, because I need to substitute in for that x. I also need to substitute in for that dx right there. A lot of people will forget that. So make sure that you're seeing that. Well, what's the derivative of tangent theta? That's secant squared theta. And yes, I chuckle. One of your classmates was asking for that during a test. I thought that was cute. You know, you need to know that. You know who you are. I'm hoping you're watching this video. How am I going to find this, though, using this triangle? What trig ratio? Now, I've got two choices. I clearly need this expression because I've got that in my denominator. I've got over x, so I could use sine as that over that, or I could use cosine. Reason why I'm going to use cosine is this 1 is a lot simpler than this x. So why introduce another x when we've already had to eliminate the, we're trying to get rid of those. So that means if I saw that, secant theta equals x squared plus 1 over 1. So secant theta equals that expression there. All right? Any questions? Any questions? Okay, cool. Well, let's just do some trig substitutions. Remember, this would be 1 over cosine, so adjacent over hypotenuse. But since who needs that, we'll just solve that in. So I've got this expression here, x. So I've got my expression for x is tan theta. Write that in there. Over. This expression is secant theta. So tangent theta over secant theta. That's that lower expression. Cool. Times dx. So I need a d theta. So I should say x, yep, and I do that. Secant squared theta, d theta. So that's secant squared theta, d theta. This is where some algebra kicks in, and I hope we could cancel out one of those. We would get the integral of secant theta tangent theta d theta, which is what? Somebody took a derivative and got secant theta times tangent theta. Well, I hope we would know that they got secant theta plus c, secant theta plus c. All right? Last step. And in years past, people have left this answer and wondered why it was incorrect. Yes, you did this integral, and it's certainly a lot easier than trying that integral. I mean, I wouldn't know what to do. We can't do, well, we could do u substitution, right? That actually would work with this one. I'll let you think about why that would work. You would still get the same answer finally. I'm just doing u substitution there, but with trig substitution, this is a little faster. Going back to your definition here, I see that secant theta, I've already got that. If I don't, I'm going to go back to my triangle. The secant of this triangle is hypotenuse over adjacent. There it is. That equals square root of x squared plus 1 plus c. All right? This next one, we couldn't have done u substitution, so let's try another one here. Again, I've got the square root of u squared plus a squared, and it would help you, I think, if you wrote that out. U equals 2x, a equals 3, right? Well, what pattern is that going to fit? That fits the pattern for tangent theta. So I'm going to go ahead and use the triangle here. I'll write this over here, and right next to it, I'm going to use tangent theta equals 2x over 3, u over a. Well, here's theta, opposite over adjacent, toa, toa, toa. And then if I did Pythagorean theorem again, I get my expression for the hypotenuse, 4x squared plus 9. And it's definitely a check that you want to do right away. If you don't get the expression that you're looking for in your integrand, you need to try another substitution. You made the wrong one. Okay? Well, if this is true, I'm going to solve this expression for x here. X equals 3 halves tangent theta. Dx, because I need that for my integrand, my dx right there, is going to be 3 halves secant squared theta d theta. And the other part that I need to substitute in is my denominator. Right? And just like we saw that one, I bet you could all get secant theta equals hypotenuse over adjacent. So that's going to be 4x squared plus 9 over 3. Solve for just that, and you'd get the expression 4x squared plus 9. Cross multiply, we get 3 secant theta. All right? So this same integral here, I'm going to set that up now. 1 over that is just 1 over 3 secant theta times 1, that was easy. Okay, so 1 over that, 3 secant theta, times, what's my dx? Well, my dx was this expression here, 3 halves secant squared theta d theta. Get that to simplify, and that 3 will cancel out. A secant will divide out 2, we get 1/2 integral of secant theta d theta. You need to know this one. You need to know this one. In fact, I found a really cool article that we're going to explore because instead of assigning you extra topics, I'm going to give you a topic to think about. So I found an article. This will be in the upcoming weeks here. So look forward to that. I'll remind you now, though, it's 1/2 natural log of secant theta plus tangent theta. It's one of those natural log integrals. So the 1/2 is going to stay. That's cool. 1/2 natural log, but again, I don't want secant theta in my final answer. Secant theta, though, I've already written that one down. So that's this expression, 4x squared plus 9 over 3 plus tangent theta. Well, I've got that one there too. 2x over 3 plus c. And that's plenty fine. In the event of a quiz or where you're looking for multiple choice for Friday's assessment, you might need to do a little bit of extra algebra here, but for our work, that's fine. All right, so again, 2 examples with the tangent substitution. Let's see if we can come up with another example here. This next one doesn't really fit in. Let me read this to you in case you're having trouble with the visual here. It's the integral, 1 over, parentheses, 25 minus x squared to the 3/2 power dx. Well, that doesn't really fit our pattern, so what if I wrote it like this, would it? The 1/2 power is the same as the square root, 25 minus x squared, all that to the 3rd power dx. Does that fit in? And of course it does. Okay, so here u is x, a is 5, and our pattern here should be what? Well, I'm going to draw my triangle here. Here's theta. To get that square root of 25 minus, I need this 5 to end up here. And I'm going to say this is our sine pattern. Sine of theta equals x over 5. Opposite over adjacent is sine theta. There it is. Solve for this missing side here. A squared plus b squared equals c squared, so square root of c squared minus a squared or b squared, whatever we want to call that. There we go. All right, so that's our 3rd side, and it matches the integrand. So again, you got to check that immediately. If it doesn't match the hard part of your integrand, you did the wrong trig substitution. So learning those rules on the front of the page are the way to go. So what does that mean? Well, if sine theta equals x over 5, that means x equals 5 sine theta. I don't need the x, but I need a dx, so that's going to be 5 cosine theta d theta. That's cool. And then I need this expression here, don't I? Well, cosine would give us adjacent over hypotenuse, So the cosine of theta equals that expression, 25 minus x squared over hypotenuse, or that square root minus 25 minus x squared equals 5 cosine theta. So we can start our substitutions. So again, remember that is to the 3rd power. Okay, so I've got 1. I've got this here, so I'm substituting in 5 cosine theta, but that's to the 3rd power. 5 cosine theta to the 3rd power. Don't forget your dx, and again, invariably, I've seen it all sadly happen before. People forget. So that's 5 cosine theta d theta. Simplify that, and I hope we could see that 5 to the 5th, and we got a 5 on the top. That's going to be 1 over 25. Get that out of the way. I've got cosine and cosine to the 3rd, so isn't that going to be 1 over cosine squared theta d theta? I don't know 1 over cosine squared, but I do know this. I forgot to put it. I'll just put it back in there. It doesn't matter. We can leave it out. Isn't that secant squared theta? You all know the antiderivative of secant squared. 1/25 tangent theta plus c. And I like this one because tangent theta, oh no, I don't know what tangent is. Sure you do. Go back to your original triangle. You know what it is. Opposite over adjacent. So 1/25 x over square root 25 minus x squared plus c. All right? I think these are fun because it pulls together a lot. So this is kind of a great way to end our grand review. This one is a little more interesting because you have a definite integral. Okay, but you could still do it. I've got the other pattern though because you've got u squared minus a squared. So let's write out what that would be. U equals x, a equals square root of 3. Oh, that's interesting. Okay. So this is the secant pattern, I'm thinking, but let's just double check. If I say secant theta equals u over a, x over square root of 3, what would our triangle look like? Well, secant's 1 over cosine, so that'd be adjacent here over x. And if I solve for my third side, would I get a squared, or c squared minus a squared, let's say? Sure enough, square root x squared minus 3. Okay? So secant theta equals that. So that means x equals square root of 3 secant theta. All right. What about an x? Well, I've got that. What about my dx? Let's calculate that. Dx is going to be what? Derivative of secant is secant times tangent, square root of 3 secant theta tangent theta d theta. Oh boy. Okay. And then for the rest of my integrand, I need that expression there. So that expression, easiest one would be this over this. So that's tangent, right? Tangent theta equals opposite over adjacent. So if I solve for that expression, I'd get square root of x squared minus 3 equals square root of 3 tangent theta. So again, I'm looking for ways to substitute in all of those x terms into trig terms. I've got x on the bottom, cool. I've got dx there, and I've got now that expression is going to be that. Now I'm going to ignore for just the moment the definite integrals there. If you want to substitute those in, great. I'm going to go ahead and plug those in after we do the antiderivative. So it's okay. We're not forgetting about them. It's just our work. So substitute in that expression, I'd get square root of 3 tangent theta. Dx might come next, so that's square root of 3 secant theta tangent theta d theta over that x, and that's square root of 3 secant theta. Make sure I've got all my terms here. Yep. This is d theta. I'm sorry, this is dx. This is that square root expression, and that's that there. Well, the square roots terms are going to divide out. One of these secants, and that secant will divide out. So you should have square root of 3 times the integral of tangent squared theta d theta, because tangent times tangent is that. Okay? I don't know if I know the antiderivative of tangent squared, but do I know something about tangent? Well, for the sake of time, I'm going to say that sure, I know that tangent squared is secant squared minus 1 d theta. Can I take this integral? Sure, antiderivative of secant squared is tangent. So I've got a square root of tangent minus, what's the antiderivative of 1 d theta? Minus theta plus c. Okay? Now, I'm going to go back and use my substitution so I can get back to 2 and square roots of 3. But if this was it, you could stop right there. It's not, so we're going to continue. Square root of 3. What is tangent theta? Let's see. I already have that one, so I'm going to write that. X squared minus 3 times this over the square root of 3. Apologize. Minus, what is theta here? Ooh. I need to use inverse secant. Arc secant theta now. Right? So I'm solving for this theta. Arc secant of x over square root of 3. And then I'm going to evaluate those limits from square root of 3 to 2. All right? So if I distribute that, I could make this a little easier. I'd have the square root of 3. I'm sorry, those divide out, so let's scratch that out. Square root of x squared minus 3 minus the square root of 3 of arc. You know, are you feeling arc secant? Or could we do arc cosine and flip that? I bet we could, right? Arc cosine of radical 3 over x. Evaluate that from square root of 3 to 2. I don't know. Do you know arc cosine better than you know arc secant? I do. Okay, so I can plug that in. All right, so now we're ready to apply the fundamental theorem of calculus. Plug in our 2 here, and we get what? 2 squared minus 3 is square root of 1, which is 1, minus square root of 3 arc cosine of, whoops, I'm missing a c there, radical 3 over 2. Right? I could do arc secant of radical 3, I'm sorry, 2 over radical 3, but most of us would know arc cosine better. Minus, plug in the square root of 3, isn't that going to be minus square root of 3 squared minus, that's square root of 0, that's 0 there. Minus radical 3 arc, whoops, arc cosine of radical 3 over 3, well that's 1. Okay, so 1 minus square root of 3, what angle has a cosine of radical 3 over 2? That's pi over 6. Minus, be careful here, 0 minus what? Well, what angle has a cosine of 1? That's 0 there, so you'd get an answer of 1 minus square root of 3 times pi over 6. Or if you wanted to get real special, you could get a common denominator, 6 minus pi square roots of 3 all over 6. Wow. Angels sang, that was a good problem. That was a good problem. A good reminder of everything that you should be able to do here. So if you're having trouble with this one, think about why you're having trouble, review those. All right? So you've got that. I'll post some practice problems, and you already have access now. So whenever you're ready, go ahead and start that quiz. I'm not timing them because I want everybody to not feel the pressure of time, but certainly one quiz every week is not too much to ask for. I'm hoping that you feel the same way. And if not, well, I can type in your grade as appropriate. So do your work. It's really not that much to ask. Hope everybody's doing well, and I will talk to you soon. Have a good one.